Good day everyone, my name is Aniket Bindu with my teammates Alek Kadam and Adesami at Ray Big Bay. We are from the Blue Frog Solutions. So Blue Frog Solution has been assigned a task to develop a commercial heavier duty application of drink-made product which can be used in restaurants and pubs. So for that we have analyzed the current drink-made system for the design modifications. We have also contacted different various restaurant and pub owners to understand how they serve the customers. So based on this analysis, we have identified the different problems. So first problem with the drink made is the limited carbonization capacity. The small size of the bottle, which comes into the size of 500 ml and 1000 ml, which is sufficient to serve one or two people at a time, which is good for the household product, but it's not cannot be used in the restaurants. So restaurants and pubs owner have shifted to the soda bottles concept. They have a huge inventory of the soda bottles which can fulfill the requirement of the multiple customers at a time in the restaurants and bars. As you can see in the below image, the customers are always struggling to get their drinks at the bar counter. So based on all these problems, we have set up the project deliverables that we have to develop a commercial soda making machine which can serve multiple customers at a time, and we can able to reduce the waiting time at the bar counters. So it will act as a replacement for the current soda bottle design, and within the one filling it can serve multiple customers with a large capacity. So based on these deliverables, we have proposed a design of 3-liter pitcher. This 3-liter pitcher comes with a handle and a pouring mechanism. So as per the customer's requirement, the proprietary part, that is infuser, and the one-step mechanism we have to use as it is in the heavier duty applications too. For that we have designed a system with an infuser compatible with the DrinkMate proprietary diffuser. It is a single assembly with the pitcher, cap and infuser, which is easy to use and mechanically operated. Also, its cost is very low compared to the high-end setups which are used in the restaurants and the pubs. So more details will be discussed by Ade, and the design will be discussed by Ade.
Thank you very much, Anke Binti. My name is Adesami Aderugwe from the Blue Frog team. I'm going to talk about the ideas that for designing the Blue Frog soda maker. These ideas are centered around keep maintaining the proprietary parts based on our client requests. The first idea we have is pitcher body design. We found two pitcher body designs, the curved design body and the straight cross-section body. We chose the straight cross-section body because it will contain more volume of liquid than the curved design body. And to minimize cost, we chose the straight cross-section body because it will be easier to and cheaper to manufacture. Our next design idea is the cap mounting. First is the bottle thread cap mounting and the J-hook slot cap mounting. The J-hook slot cap mounting was chosen because it was part of the proprietary parts we're maintained based on the client requests. The next idea is the mechanism for pouring the liquid. The first was a rotating lid mechanism, which had problems due to high pressure. It would be hard to open and hard to close. Then we looked at the push button mechanism, which was better than the rotating lid mechanism, but had a problem with pouring the drink. It was uncomfortable to press the button at the same time pour the liquid from the pitcher into the cups or for the customers. Then the last one, and the one we chose, was the press button, which will be easier to press at the same time pour the drink or liquid into the container of the customers. It's more comfortable than the push button and the rotating lid mechanism. Here is our design requirements. Like I said earlier, we are meant to maintain the proprietary parts based on the client requests. All our design ideas are designed around the proprietary parts. The second is cap mounting should stand 3 bar pressure. That is the amount of pressure available in restaurants and pubs, which is higher than the pressure available in households. Due to our design for commercial uses, we are going to create the model to withstand high amount of pressure for restaurants and bars. Airtight fitting. Our model is meant to be able to store the carbonated liquid and keep it carbonated for a long period of time. So we're meant to make the pitcher to be airtight. And human ergonomics, like I mentioned earlier, the press button will make it easier to open the pitcher and pour the drink or liquid out and release, and the pitcher will be sealed back, which will keep the liquid carbonated for a long period of time. Next is the design selection and card layout, which my colleague Aniket will explain further. Thank you very much.
Thank you, Ade. From here, I'll take. So I'm going to speak about design selection and CAD layout, team performance, and design assessment. As we decided previously during our brainstorming period that we are going to use straight cross-section picture. As you can see in this image, there is a straight cross-section picture with a flat base. This is what we planned, and this is what our CAD model is. There is a handle considering the human ergonomics which can be held very efficiently and easily. This push button will be pressed by thumb, so this distance is also maintained. There are two rubber O-rings to avoid air leakages, one at this end and second at this end. This is to direction the flow of soda or whatever liquid is it in the pitcher. These are the J hooks and J hook slots that are used to mount this cap on the pitcher body. These J hooks can withstand 3 bar pressure as they were previously used in the Brinkmet bottles. Further, we came upon with the selection of press button. As you can see over here, we decided not to use push button and rotating lid mechanism because it has minor design flaws. I'll discuss them in the design assessment. But over here, you can use the thumb to press this button so that this member will move in a translational linear motion inside, opening the knob at the other end, and the spring will compress. Upon releasing of this button, the spring will expand and this knob will come back to the same position, closing the main lid. Over here are the two rubber O-rings that are used. As you can see, this is at the start end and this is at the pouring side of the pitcher. At the start end, this is so tight that it will minimize, literally leave no air space for air to leak. That is, soda won't leak, changing your taste of the sparkling water or soda. And this is at the next end where the pouring end is, and this is also to the same. Further, I'm going to discuss about the design assessment. So to compare this chart, we used three elements, like three models which were planned in scope. Like the model we decided using the scope which was given to us, the conceptual ideas which we came up with during the brainstorming phase, and the actual results that are already shown and are built by us in the CAD model. We used the design requirements, deliverables, technical constraints, design flaws, and customer satisfaction as the key elements to identify these three models. And these three models are rated on the scale of 0 to 5, as you can see. I'll discuss majorly the design flaw as it is having a major gap between the highest peak point and lowest point. That is, the design flaws in conceptual ideas were identified most. We were trying new concepts to implement in our picture so that we can make it more better. But the more work we did, the more scope creep was created, the more design flaws came out. So we decided to change that while bringing it into the actual model. When we created our actual model, all the design flaws were minimized, and that's why we only have two over here for actual results. Our team performance was up to the mark till the project is complete. We mainly concentrated on communication. We built a very good communication and made sure that everyone remains communicated with whatever upbringing or updations are going on in the project. Our team's efficiency, individual efficiency was very good in every task given to them. Each and every task was accomplished in time according to the milestones. Brainstorming done by everyone was equally respected and brought into a common conclusion. research was done by all, and there were used in this our project work too. There were minimum level of conflicts in our team, as we had most of the common results of any problem, or we had common solution for any problem that we faced. This is how we came up with the best product we could possibly do, and we came up with a blue frog picture with our 100% of teamwork efforts. That's all for the presentation. Thank you. For further queries, you can contact us at this number or shoot a mail on this email ID. Thank you.